In this video, we are going to talk about prosthetic polymers and resins. So, first of all, what are prosthetic polymers? Any kind of polymer, either prosthetic, dental, or any kind of polymer in our lives, is a repeated unit of many monomer units. Monomer units, in these case, for example, PMMA, we have monomer units as methyl methacrylate, which further joins to form a polymer unit of polymethyl methacrylate. There are many copolymers also that forms a cross-linking, and hence a polymer is formed. So acrylic resins are polymers of acrylic acid, methacrylic acid. That is, these are resins made of polymerization of esters of acrylic acid or methacrylic acid. Now, according to ISO, the classification of polymethyl methacrylate resin are heat activated, or second, autopolymerized or chemically activated, then thermoplastic blank, fourth, light activated resin, and then microwave cured resins. However, based on usage, they are classified as temporary denture-based resins and permanent denture-based resins. Resins include resin that we have mostly used in our labs for making our base plates, that is denture-based, before processing the denture. Shellac-based plates that are used for making base plates similarly to the self-cure resins, and injection molded resins. These are recent advancements. Permanent denture based resins include heat cure acrylic resin, light cure acrylic resin, and recent advancement as pore type resins. Now, the classification based on method of activation. It includes heat activated resin, autopolymerized or chemically activated resins that uses the normal reaction, that is dimethyl paratoluidine reacts with benzoyl peroxide to initiate the reaction. Then light activated resins. Now the composition of the denture based resins. First of all, heat cure acrylic resin. The powder and liquid constituents are found. That is, we use these heat cure acrylic resin in two forms, that is powder and liquid. The powder consists of polymethyl methacrylate, ethyl butyl methacrylate, benzoyl peroxide, compounds of mercuric sulfide, cadmium sulfide, zinc or titanium oxide, dibutyl phthalate, inorganic fillers like glass fibers, zirconium silicate, alumina, etc., and dyed synthetic nylon or acrylic fibers. So, functions of these ingredients are given as the polymethyl methacrylate. It is the major component, that is the polymer of the heat cure acrylic resin. Ethyl or butyl methacrylate acts as copolymers. It improves the properties of the resin formed, and these are used in formation of cross-linking in the heat cure acrylic. Then the benzoyl peroxide, it acts as initiator in the reaction. It breaks into free radical form to initiate the reaction. Compounds of mercuric sulfide, cadmium sulfide, these are acting as dyes that imparts the color to the resin. Zinc or titanium oxide acts as opacifiers, that is, if we don't want to if we don't want the underlying substance or underlying tissues to be visible, so we add opacifiers so that the underlying tissues are not visible. Then dibutyl phthalate, this acts as plasticizer, that plasticizes the resin to give the strength. Inorganic fillers, these improves many physical properties like stiffness, hardness, etc. Then dye synthetic nylon or acrylic fibers. These simulate small capillaries and acts as fillers. Liquid consists of methyl methacrylate, that is the monomer unit of the heat cured acrylic. So it plasticizes the polymer. Dibutyl phthalate, it acts as the plasticizer again. In the powder, it was also acting as the plasticizer and it is also present in the liquid. Then glycol dimethyl acrylate. This acts as the cross-linking agent. That is very important. The cross-linking agent forms crosslinks that will be described later, that reduces grazing. That is it's kind of scratches, if you can see, or if you have made base plate, so there are many kind of imperfections or holes and these kind of scratches, so this is grazing. Hydroquinone, it acts as the inhibitor. It inhibits premature polymerization. For example, if we keep the monomer liquid in sunlight, it will automatically polymerize with the help of heat provided by sunlight. So to inhibit this kind of polymerization of the monomer liquid, we add hydroquinone to inhibit the premature polymerization. Then cold cure acrylic. The composition of cold cure acrylic again contains liquid and polymer powder. The ingredients of the liquid are methyl methacrylate monomer, that again, as in heat cure acrylic, plasticizes the polymer. Dimethyl paratoluidine, that I have already told in the previous slides, that it acts as activator, which converts the benzoyl peroxide into a free radical form to activate and initiate the reaction. Dibutyl phthalate acts as plasticizer. Glycol dimethyl acrylate acts as cross-linking agent. Hydroquinone is the inhibitor. Now the polymer and powder. So polymer or powder consists of main components as polymethyl methacrylate and other copolymers that form the resin matrix, and benzoyl peroxide that acts as initiator, compounds of mercuric sulfide, cadmium sulfide that acts as dyes, zinc or titanium oxide that acts as opacifiers, dibutyl phthalate that acts as plasticizer, and dyed organic fillers and inorganic particles like glass fibers or beads. These are added as aesthetic components of the resin. Now, light cure acrylic resin. It consists of polyether urethane dimethyl acrylate, that is the major constituent. So, what is this urethane? The urethane is the major component because any type of material that needs to be light cured is does require a urethane molecule. Without it, it can't be light cured. Now, photoinitiator is the camphoroquinone. Amine is the photoactivator, and silicon dioxide inorganic components acts as fillers. Acrylic resin beads also acts as filler, organic component, and the high molecular weight acrylic resin acts as monomer.